slide we have now, how creating a cable, crypting a cable to RJ45 connector follows the following. You have to follow this step, okay? Follow the following step, okay, all right, it's grammatically correct actually. All right, now crypting a cable to RJ45, the first thing you need to do when you procure your wire at the market and you want to do maybe your home networking, you want to network your system at home, your printer and all, you want to link all together, and also the internet of things, you know, you can link your camera, your external camera, your speaker and all. So in order to do that, you follow this procedure, and if these procedures are duly followed, yeah, you can rest assured that your wire will allow the passage of data frame. Okay, so now let's see this. I believe I'm audible enough. Okay, so now the first step you need to do, I say having procured the wire from the market, that's twisted pair. It could either be UTP or STP. Okay, UTP means unshielded twisted pair, and while STP means what? Shielded twisted pair. Okay, now either way, either one of them, so you have to cut. You say cut plastic sheets about 1 inches from bottom cable, from both cable terminals, that is terminals A and B, not with what? The teeth. Not with teeth. You must be very careful as a network engineer. You need to buy two. You are going to see all those things by God as we progress. So not with teeth. You know, if you want to do your wire at home, maybe electrical wire, sometimes we can use our teeth. We have been tempted to use our teeth, but in network connection, in wiring, in network wiring, you don't use teeth. Okay, you use the standard tool. Okay, so with a razor, blend in the network tool part. Okay, now look at it, 1 inches. If you look at this edge, this is a terminal of the twisted cable. Now this is a terminal and this is an insulator. Can we all see it now? I believe we can see it now. From here to this place, according to the standard, it should be 1 inches. 1 inches. Okay, you remove the sheets, the plastic sheet, you remove it, you cut it in 1 inches. Okay, so having cut that away, now the step 2, unwind. You can see, why do we call it twisted pair? Because each of these pair, they are each of them is twisted. Can you see? It's twisted. Can you see? All these are twisted. So for you to, having cut that sheet 1 inches away, you have to unwind it to make it untwisted. Okay, so and you will straighten it and say unwind and pair the similar color as seen on the previous schema like I've shown you. So you have to arrange the color as seen initially. Before now, you are going to arrange it. You can go back to the slide. Then okay, before then, this is what? Twisted cable, and this is what? RJ45 we've been talking about. Can you see there are 8 pins here, 8 pins, and these are 4 pairs. Okay, and each pair has 2 wires, so it makes it 8. So 8 goes into the 8th cable. Okay, now step number 3 says straighten wires with fingers and keep it in order required. Okay, the order required, we are still referring to what we talked about here, the order of the color. So you have to make it straight. You straighten all these twisted wherever, you remove them, you make sure you unwind them and make sure that they are straight. You don't use machine for that, you use your hand to do that. Having cut the 1 inches, having unwind it, you will now use your hand to straighten it one by one, and consider the arrangement, the color arrangement. If you are following the T568A standard, you have to arrange it according to that color. If you are arranging it in the T568B, you have to arrange it in that order. Okay, so now the step number 4 says, now make a straight cut across the 8 wires with scissors to make the 1 inches as half, to make 1 inches and half. So you have to cut that 1 inches. Like now, having straightened this wire, you will now cut half of this away so that they will have equal mouth. They will be equal. No one will be taller than the other or shorter than the other. You have to cut it equally. Can you see? You cut it across, then you have that. Okay, now the step number 5, insert the 8 color wire in the RJ45 and allow the plastic sheet to properly enter the RJ connector. Can you see? So this wire now, the 8 that you have straightened very well, straight, and you have cut, and all of them have equal height, you are going to put it inside this RJ45. You put it there according to that color. You put it inside it. Then comes what we call creeper. There's something called creeper. You're going to see the image if you have not seen it before. Then lastly, insert the RJ45 connector inside the creeper and push on its ends tightly. Having pushed it, you have to clip it. You press it very well so that it can be firmly fixed. Okay, now without further, let's move to the next. Let's see the type of network we have. So the type of network we have, so we have the LAN. We've heard of the type of network before. We have WAN, we have WAN LAN, we have MAN, we have CAN, we have SAN, we have PAN, we have DAN. So those are most of them. They are ancient type of networking, but the one that are trending now are LAN and WAN. LAN means local area network, and WAN means wide area network. Okay, so now let's move further. Are we together? If you are together, can you give me a thumbs up? Are we together? Okay, all right. Are we together? All right, okay. Please, if we are together, can you give me a thumbs up? Okay, good. All right. Now, we have seen how to creep physical medium. That's the RJ45 with the cable. Okay, now let's proceed. Network also has something called the geometrical arrangement. Okay, that is the term called topography. And many people have heard the word topography, network topography. What does that really mean? It simply means what? The arrangement. That's just it. The arrangement of network. That's just it. This is the geometrical arrangement of node. The node. These nodes are computer resources, communication devices. It could be system, phone, printer, and all. There are various type of network topography. We have box. That's the first one. The first thing that will come to your mind is that. So you will see how it goes. We have the ring NT. We have fully connected NT. We have mesh NT, and we have star network topography. So in that state, let's look at the diagrammatical representation of those. So if you look at this, the box form, this is it. Can you see? Is a line connection in which each line, the communication passes through one node to the other, to the other, and to the other. If you look at this, the connection in electronic, they call that series connection, right? So this is a series connection, okay? So it goes, the communication, let's assume this one, can you see my cursor? Okay, good. I believe you can see my cursor, right? So if this node here, the computer, the PC here, serve as server, and you want to send something, information, so when it sends the information, it pass through that medium, okay? It pass through that medium. So in this state, are we together? Are we together? My network, okay, yeah, good. Okay, good. So this is what, this is star empty, this is ring empty, this is fully wired empty. All of these arrangement topographies, they each of them has its own benefits and its own what's it like called, advantage and disadvantage, okay? We have disadvantages and advantages, okay? So disadvantages that this particular we have, like in e.g. this ring and the fully connected NT. the the disadvantage of this one, the first one, that is ring NT, means that when a message is passed, is is depending on other node. So if I'm passing an information and it reaches a node, let's assume one of these node, I'm passing an information from here to all of them, right? It's broadcasting information and it will go anti-clockwise like this. It goes like this or wherever, any direction. So this is monodirectional, okay? So when it goes like this, for this one to receive the message, it must reach this place and this particular node must pass it to this one. Let's assume this node, this very node, got crashed or something happened to it. It means the message perishes with it, okay? It won't go further. That is the disadvantage. So then we now have this fully connected. So even if this fully connected, each node, they are what, independent of other, independent of other. So if one gets spoiled, it won't affect other one to receive the information. Can you see it now? So you can read more about that, okay? So let's proceed by going to that, to the next one. We have network interface. Network interface, I want to show you that on the Cisco packet tracer. So you see this interface, the wireless interface and the wired interface, okay? Now going through that, we have network are built by adding a network interface card, NIC. I believe you've heard of that before. For your system to work with internet, for your system to be connected to other network devices, you must have what we call NIC. That's network interface card, okay? Or other network adapter or adapter to computer, and then connecting that adapters to the medium, that is wire, connecting it to the, you are going to see that. Let me just move further. So these are the devices, the enhancer, the network interface enhancer, okay? We have hub. You've heard of that hub before. What is hub? Hub is like an extension. It's just like an extension. So let's assume you have a socket on your wall. That socket is working perfectly well, but you only have one port. Let's assume you have you have fan, you have television, you have, let's say 5 electrical gadgets, and you want to plug it on a wall socket just that has only one port. You know, you can only plug one at a go. So for you to have access to that one port and plug all your gadget at the same time, you need to buy an extension. So what is an extension? Extension is you just plug it to make sure that the current circulates to other ports that will enhance, you know, you to plug to other to those let out and make all your devices to work at an instant, okay? At very simultaneously. Not that you plug one, you remove and plug another one. No, you plug it at the same time, you now on it, depending on how. So the same thing applicable to hub. Hub is just like that. Hub receives signal from each machine from wire connection. So when you pass something from the server to other computer, the hub does not, you can't send a message to a particular uh, device. Probably you have 10 devices on the network and you want to send information. That information you are sending through hub will not send it to a particular node. It will send it to all nodes on the network. So it's only the switch. That is why the switch now comes in. So probably in the network where I want to send to I want to print, I want to send to printer. It will not broadcast on all of other devices on the network. It will go to that particular one with the IP. It goes there straight. Okay, switch does that, and that is why the definition says a device that makes connection between specific devices on a network by sending and receiving data between them. When a signal enters a port of switch, the switch look at the destination address of the frame and internally establishes a logical connection with the port connected to the destination node. Okay, good. Now the other network interface device, we have what? We have router. The router, a network device that connects multiple network together. And don't forget, I define internet initially when we started. That internet, not all internet are no okay, all internet are network, but not all network are internet. Okay, now what makes network to be internet is the enhancement of that connection to access global resources. The enhancement of that network to access global resources. So what enhances that local network connection you have to the outside world data, or outside of your network data, is what? Is the router. And it works with this one too. Is very 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 interesting. So this particular router, it uses SIP, ISP rather, ISP. What is ISP? ISP means internet service provider. So it work with it, like e.g. like network, the network we are using, like I'm using MTN router, right? The MTN is one of the ISP that provides us with internet facility, okay, that enable me to access other resources from other way, from other system, from other local location. Okay, so that is AISP. So the router enables the local connection for global resources accessibility. Okay, so a network device that connects multiple network together, so that is what? Router. Okay, and if you can see it, they say it's the ability to connect the similar LAN on the same protocol. I've told you about the LAN. That's local area network to other network. Then that makes it what? WAN. That's wide area network. Moving forward. Yeah, the two. So if you are interested, or you've been in the field but you don't know about the two, probably, so these are tools that are very very essential for you, most especially this creeper, the creeper and the tester, then the scissors, which is very important because you will not be using your teeth to cut it. Okay, you will need the scissors. Although this creeper too has the scissors, you can use this. The end of this creeper is very sharp. It's like a scissors. That's what I normally use. So I use this when then so this we use this to cut. Then when you use this to cut, you can equally use seal your blade, the blade, this one, this yellow one, to cut it so as to remove the sheet, the plastic sheet from it, and be able to cut that one inches. So at the mouth of this clipper is what RJ45 mode. So when you put the wire into the RJ45, you now put it inside this clipper, then you have to hold it tight. Don't forget the steps on how to clip the cable to your RJ45. So this is the clipper they are talking about. So, and this tester, what does it do? It checks on the continuity of the flow of data, or signal flow of signal in the crypted cable. So when you finish crypting your cable, the A terminal and the B terminal, you are going to fix it inside this machine. Then this machine will now show you green. If it shows green, it means it is well done. Then if it show other color, it means it does not follow what the standard. So you have to do it again. And mind you, any wrong connection you do, any wrong clipping you do, you have already you've already wasted the RJ45 like that. You cut it away, you use a new one, a fresh RJ45, because you can't fix it again, because once crypted, you've already deformed it. So if it is not properly crypted, you will cut it away and use a new one. Okay, good. Now let's continue. We have other thing here, and probably you are giving a contrast to wired a very big structure or school, wherever, and you have done some inner. So you know we have two type of wiring. Let's say electrically now. They have surface and what's they call it one name. I've forgotten that now. So yeah, surface and the one you pass through, conduit. Yeah, conduit. We have surface and we have conduit. So the same thing to networking. You can have conduit and surface. Both of them still have advantages and what disadvantages. But however, if you are wiring it, you know you will not be able to be testing. You can't be okay, I want to use a particular wire, which one has gone to this switch, which one has gone to this up. I want to know how. So we have a tools that can help you to do that. Probably you have 3-story building and the major hub is in the first story building, and you are at the last story building, and you want to know. You can't be tracing wire and be breaking wall. You can't be breaking wall. What do? You use a tester. There's one tester here also. So this tester has 2 pair. You put one inside the terminal of the wire you want to trace, and you will now be using the second one to be touching the other cable at the place you are. So when it make a sound, it means you have already identified that cable. So finally we have miscellaneous TD. Miscellaneous TD, that's the terms definition. The LAN means local area network, and of course that's that. So I want to show us something on, let me show us something on the packet tracer. Let's see, before I move on. Okay, let me show us something on this. Let me see. Hi, can you see my screen? Hi, can you see my screen? Okay. Okay, I think I've moved forward. All right, so good. Let's see how this thing works. Okay. Good. All right, this is Cisco Packet Tracer software. Okay, so what does this software do? It actually helps us. So it helps us to visualize and also implement network connection even when we don't have the physical devices to achieve that. And one thing that interests me with this software is that any connection done logically on this software can be implemented when you have the system, when you have all the gadgets. So that is when you want to do a very gigantic maybe network connection, you can use it to implement it. And if your data are well, they are the node are well networked together, and this you check, you ping it, and you see that the connection, the packet passed, or the data packet passed, nothing missing, it means that the connection is well fixed. So you can implement it physically, and it will uh, uh, be good, and it will work very well for you as well physically if you follow that. So it is very essential we use that to implement connection. So now if you look at this, let me remove this and put another one. Let me remove that and put another, and show you how that connection is done, and show you NIC, that's network interface connector. Okay, okay, let me open my, okay, I believe you can see it there, right? Good. Let me remove the, good. So let me delete, let me create another one. So now this is the Cisco Packet Tracer, and it is used to visualize networking. You can implement your networking settings out here, then physically you can implement it. So when you don't have the resources to buy all the the nodes you need, maybe to computer to test your knowledge, you can actually go ahead and test your knowledge with this Packet Tracer. Okay, so Packet Tracer has, this is the interface. So the first interface we have, this one is the tab, we have the file, and so on and so forth. We have file, we have all this icon here. So this icon is to zoom. Can you see? You can use it to zoom out, zoom in. Then this is to delete. Probably you want to delete. You saw me when I was deleting something, so you can use this one to delete and all. This one for dragging and all. Then yeah, the third bar we have logical and physical. So if I select physical, you see the options at the right hand side changes. Okay, so meaning they depend, what you see at the right hand side depend on what you select at the left hand side. So logical connection, let's add something. So down here, this is where the pin where we put the connection, when we add all the connection. Then down here we have hide the node, the internet devices, the network devices rather. The network devices, the first one here we have the category, which is network devices. Can you see? So having click on network devices, we now have sub network devices. So if I click on it, you can see sub category changes, right? So here also changes. So as soon as you click on the network devices, we have router, but let's select home router, or yeah, let's select, we've clicked on this, then let's select wireless device. So when you click on this the description, I believe you can see what I'm doing. So when you click on wireless devices, here also we have other information. So you can see each of these subdivided devices has its own types. Okay, so now let me click on home router and drag. You click and drag, drop it. So this home router, you can change the name from wireless router whole to whatsoever name you want it to pair. Okay, so you can just give it, let's say, WC high. So okay, good. I believe you can all see it, right? Good. So let's now, this is our router. This is our router, so I need to equally show you. So okay, now let's bring in device, the end device. So the end device, let's bring up PC and also a laptop. So we're going to be doing the two connection, the two medium, that's wired and wireless. So good. So let me do the connection. If you see my cursor here, the hand pointing towards this is a connection. Then can you see connections? So this connection has, the first one has different type. So you can do automatically, you can automatically choose your connection. So let me click on that automatic, correct. So having clicked on that automatic, you can see the cursor change to like a wire. If you look at it, like a plug and wire. Okay, so what you do is to click on the router, this home router, click on it. Can you see I've clicked on it? Then drag your hand across to the PC. That green shows perfectly connected. Okay, I believe you can see what I'm doing. Are you there? Are you there? Okay, so for the, this is the wired medium, wire connection. So let's look at the
Yes, sir.
all right, okay, thank you. So let's look at the other connection, that is wireless. So for the wireless, let me equally share the screen so that you can see it here. Okay, wireless. So excuse me. Okay, all right. Okay, yeah. So for the wireless, you click on the laptop, that system, you click on it. Can you see it? And if you can't see it, let me just add that to it now. Okay, excuse me seconds, let me fix this. Okay, good. Good. Can you see this? Can you see the good? Can you see it? All right, so now I clicked on the I
Yes, sir.
okay,
We
good.
can see.
Okay, so clicking on the laptop, we have the physical representation of the laptop. Can you see it here? So we have switch on, turn on. Can you see this option here? This, can you see where I'm pointing to? That's switch on, the power button. You switch on. Can you see the green light? Then switch off. Okay, so we want to remove this interface. You know, we talked about NIC, that for any device that must be on network, it must have an interface, network interface. That network interface could either be wired or wireless. So this one, this system has a wired interface, NIC. Okay, so we want to remove it because we want to implement the wireless connection. So what do we do? First and foremost, for you to change anything in your laptop, you switch it off. Okay, that's off. Then drag it away from there, away from this side. Then bring in WP, that's WPC. So put it there. Can you see it now? That is wireless connection. So let me close this. Let me close this and see what. Okay. Alri- Okay. Good, good. Are we together? Then switch on the system, the PC. Then can you see it now? Okay, good. Good. You can see that dotted line now has comes up, right? The line has come up, right? Good. So that is wireless connection. So because of our time, let me stop here. So that we've exhausted all the slides. So I will make the slide available, and to further continue with this learning, I've added some link to the slide as well. So through to Cisco free camp lectures. Okay, thank you.
I'm really grateful for this session, and I really learned a lot. And I believe that everyone on this on live session too really enjoyed this session. And let me thank everyone specially. Thank everyone for joining today's session. It's really an insightful one. Yeah, networking fundamental for IT professionals is a very interesting topic, and Mr. Sunday Afolabi, P. Afolabi, has really done a great job by breaking these things down for all of us.